Alright, so for our next lesson, we will start with two new libraries. As I said in the previous video, libraries are those books or reference material that C++ uses to carry forward the whole program. So through a course of studying C++, we'll encounter a lot of programs which makes use of mathematical functions. It can be trigonometric functions like sine, cos, tan. It can be logarithmic functions like log, natural log of a number, or it can be something like finding the square root or finding the exponential value of a given number. And for that, instead of writing a long humongous code for that, C++ has made it easier for us to make use of certain functions that have been predefined before. That means there is a library, alright, by the name of Math.h. So what I'm going to do here is I'm including this library Math.h, right? And a lot of functions like sine, cos, tan, log, all of that is included in the library Math.h. Now let's see some of the functions that we'll commonly be using in CPP programs in the near future. So let's start by initializing a variable I as 9, right? Now using this library Math.h and using this number 9, we can find log of 9, any trigonometric function of 9, we can find the square of 9 or 9 raised to any power, and we can find the square root also. I'll be showing you the syntax for each and every one of them. So first we have the root, right? For root we have a very simple function which is given by sqrt, which basically is an abbreviation or a shortened version of square root. Square is given by sq and root is given by rt. So square root of the number I. That will give us the square root of I, which is 9. Next one we have the power function. Now I'm going to write square here, or for simplicity's sake I'm going to write cube here. Okay, we're going to write cube, or we're going to write a function to find the or we're going to avail a function, not write a function, I'm sorry. We're going to avail a function defined by Math.h to find the cube of the number 9, right? And that is given by the function pow, right? Pow stands for power, right? Now the power function has two parameters. Every exponential value you want to calculate has a base and the exponent, right? So if you want to calculate 9 raised to 3, we'll write 9 comma 3 here, the base first and the exponent. So in this case we are making use of the variable I. So instead of 9 I'll write I. So with this function over here, I can find the cube value of the variable I, right? And after that, if I was to find sine value, right, of I, is as simple as writing sine I. That's it, very simple. At the same time, if I want to find log value of I, it follows the same step, that is log I. Let's just execute the program and see what the output is. Let's see. Root of 9 is 3, cube of 9 is 729, sine of 9 is 0.412. Sine value will always be in radians, that's why it's given like this, right? At least that's what I think it is. If I'm wrong, please be sure to correct yourself. Then the log of 9 is also given. Now a simple log of I means it's the natural log. If I'm to write log 10 here, I'll show. If I'm to write log 10, that is not natural log, it is the log with base 10. So the value will change. Right, see, it has changed. So that's it for Math.h. It's a very important function when it comes to finding out squares of we will be using it to find squares of numbers in the basis of patterns and some programs similar to that. Right. Now we'll move on to jump statements in C++. Now this jump statement might be familiar to you all, and jump statements are mainly of 4 types. I recall, I think it's 4. One is exit, the other one is break, then we have continue, and last we have go to. So right off the bat, I'm going to show you the exit function. That's the first jump statement. Now to give a small introduction about jump statements are those statements that help you to avoid certain part of the code, or to selectively move out and only run certain parts of the code. Now if I say like that, most of you won't understand what I'm saying, so I'll just illustrate. Now to use exit, we'll use another library known as process.h. It's very important to keep in mind these libraries and their functions, because it helps us to understand when to use these functions. To be on the safer side, when you're writing a program, include all these libraries. So even if you involuntarily use one of the functions belonging to any one of these libraries, you won't get an error, right? So if I'm writing here, the program will not display anything after this, right? And I am giving the function exit here. Okay, exit 0, that's the passing value, just like return 0. Exit 0 is the syntax, right? So if I'm executing, see, the program will not be displayed after this. All these statements over here, the root, cube, sign, log, all of them were skipped just because the compiler saw the exit sign. So in the mind of the compiler, first it reached this sentence, it was about to go to all these sentences, but it saw the exit sign, right? When it saw the exit, it directly jumped over here and got out and terminated the whole program. So that is our number 1 jump statement. Now the next jump statement we have is go to. Now go to is a very simple jump statement. How we start go to is, we initialize a character, right? Let's say char ch, okay? Let it be there, just a random character. Now I'm going to write, or right after this, I'm going to write this will get repeated again, okay, and slash it. Okay, and I'm going to write go to ch, and the syntax asks us to give a normal terminating semicolon here, and what we have to do is, wherever we are going to, or wherever we need this repetition to happen, we write ch with a colon, right? And if we execute, you'll see what happens. Right, in this case we created an infinite loop. Let me try to do that without creating an infinite loop. A simple if statement, right? Plus plus I, right? If I is equals to 10. Okay. Now over here we have another lesson, small lesson over here. If you want to compare values together, we use 2 equals to signs, right? If I were to write I equal to 10, means I has a value of 10. But if I'm to write I equals to 10, the compiler or C++ is comparing I's value and 10's value together to see if it's same or not. So essentially what I'm asking to do over here is, I'm incrementing 10's value first. Then I'm checking whether I is 10 or not. If I is 10 only, the go to works. So we're not having a repetitive infinite loop. Now if I run this program, see, this will get repeated again, happens twice. Why? First the compiler, I was 9, the compiler went all the way here, increment happened, so I became 10, and over here compiler is asked to go to ch. So compiler directly searches for ch and it found ch, right? So it goes all the way back there and it repeats the code all the way again, and again an increment happens, so it's 11 now, I is 11 now, so this condition does not happen and it gets terminated. So go to statement basically is an order that we are going to compiler. We are telling AC++, go to that place, right? And it obeys us and goes to that place. It's as simple as that. So reviewing again, exit is an order telling you to stop, telling C++ to stop the entire program wherever it is called. That is the exit statement. For go to, we are asking C++ to go somewhere, and it obeys us and it goes to that place, and then it repeats whatever line of code that we have written until it encounters the go to again. Right, now the next jump statement is the continue, and to illustrate this we require a simple loop. So I'll be making, I'm just deleting that code over there, I will make a simple loop for int I equals to 0. I really hope every one of you remember the syntax for a simple for loop, plus I, right? And as you can see from this loop, i's value will move from 0, 1, 2 and 3, right? So in any way we'll get 4 outputs, 4 iterations, okay? For iteration as in 4 repetitions of this loop, right? Now I'm writing cout /n boring, okay, wait, boring sentence, okay? But before this I'm writing if and only if I equals to 2. We are comparing the value of I and 2. Whenever I becomes 2, I want a separate sentence to be said. /n exclusive sentence for I equals to 2. And I'm writing our jump statement, which is a simple continue. Notice how it became bold. That shows that continue is a keyword, and a keyword is a reserved word. That means you cannot use continue without the double quotes anywhere in the program, because C++ identifies it as a functional word, and that means it has another function. So you can't simply use this word unless it's between the double quotes, right? So I've written continue. Now by theory what is supposed to happen is it is the loop is supposed to go from 0, and that time this sentence will be executed. 1, this sentence will be executed. When it reaches 2, this condition is satisfied, so it displays this sentence, and right after that the C++ sees this continue. So what happens is C++ is like, okay fine, it told me to continue, so I don't have to look through the next or the rest of the part of the loop. I'll go to the next iteration of the loop, and so it cuts from here and jumps over here, right? Now when I execute the program, it will be easier for all of you to understand. See, when I was 0, boring sentence was outputted. When I was 1, boring sentence again. When I was 2, only exclusive sentence for I equals to 2 was outputted. Boring sentence was skipped because C++ saw this continue sign over here, and so when it saw this continue sign, it jumped right back to the next iteration. Now before we move on towards our final jump statement, it would be very useful for us to learn about switch. Now switch is this it's the substitute for an if-else-if ladder. Now instead of explaining this by words, I'll show you a small program. This is a simple program which intakes a value I. I'm going to write enter a number between 1 and 3, right? Between between 1 and 3. Okay, and then I'm writing C in I. Okay, I'm intaking that value from the user. Now all I want to do is, if it's 1, I have to print it is 1. If it's 2, I have to print it is 2, and so on. So if I'm using if, the program will look like this. If I equals to 1, see out it is 1, right? And then it will be else if I equals to 2, and then we'll have it is 2. Then we'll have one more else if I equals to 3. Same thing will happen again, but this time it will be 3. Let's execute this program. And we have a small program where I am entering 2, right? So its inputs, it shows an output of it is 2. As you can notice over here, this program is very chunky. Okay, now in this example, it might not be very chunky, but for many number of conditions, if the conditions are more than 3, in this case only 3 conditions were there, that's why it's relatively short. Now if there are like 7 or 8 conditions, we'll have to give if else until the 8th condition is written, and that can be very discomforting to look at, or it can be very tiresome and boring to type, and it will take up a lot of space in C++ coding. So to avoid this, we make use of a switch. So the syntax of switch is that we first write switch, and we have the rounded brackets, and in the rounded brackets we have the variable that we want to check the value for, that is I in this case, right? And after that we are going to write the cases one by one. That is case if I is 1, that is if I is 1, we'll write it is 1, and we'll write break. Now here break is our final jump statement, right? Now I'll show you the significance of break through switch. Now I'm going to write case if I's value is 2, right over here. I'll just copy this whole thing so that I don't have to type it again and again. It is 2, and last we have case 3. It is 3. As you can see, it's very much simpler as compared to the redundant if else statements. Now in switch there is this option for default also. Now default statement basically tells switch that if I's value is some other random value, if I'm inputting 5, right? If I'm inputting 5, basically that means that none of these cases will work for the input I've given. So if none of the cases are satisfied, the switch has this mechanism by which, or it has an option by which we can write a default message saying that you picked the wrong number, or any custom message can be conveyed by this default statement, and we write a break also. And now if I'm executing this program, enter a number between 1 and 3, I'm writing 2. Okay, something went wrong there. Yeah, I forgot to put the cout statement over here. A very dumb mistake. Okay, cout. Alright, now I'm executing the whole program, and 2, and it writes it is 2. Now if this break statements weren't there, what would happen to this switch? That is what we are going to look. I have deleted all the break statements here, and I'm executing. Now if the input was 1, I'm writing 1 here. It is 1, it is 2, it is 3. So as you can see, if you don't put a break here, and if I'm inputting the if I'm giving I having value 1, it will print this, and it won't stop there. It will go to the next sentence, it will go to the next sentence, it will even go to this sentence also. So to avoid this, we are putting break here. Break basically tells, fine, you chose your option, and right after the options statement is outputted, I am breaking from the entire switch. Right after this case is satisfied, I don't have to look at any other part of the switch, so I'm getting out of the switch. So that is what break does. It breaks free from the switch. So in short, in this session we learned first about math function, the different mathematical functions that we can carry out in C++. Then we learned about jump statements. The first one being exit, which helps us to exit the program at any point of time. The second being continue, helps us to skip some chunks of code in a for loop or in any kind of loop and go on to the next iteration. The third, we had the go to, which orders C++ to go to the label or whatever point we have asked C++ to go to. And fourth one, we have break, which is a very important key component of switch. And switch is used in position or instead of nested or repetitive and redundant if-else statements.